Good morning, my learners. As we indicated yesterday, for those who watched the broadcast yesterday, that today we will have some time to talk on the key basic things that we need to consider when we get to answer the questions on geometry. As we have learned it from the junior grade 9, 10, 8, 9, 10, 11, Euclid geometry as well, circle geometry, and everything that relates to geometry. We will be talking about those basic things that we need to look for when we work on the questions for Euclid geometry. Remember, we said every time when you come to this section in your question paper, do not quickly run for the questions themselves, but it is important for us to always look at what information do we get and what can we read from the diagram. I'll just want to show you this diagram here, that if you look at this diagram here, like we say, there is a list of questions at the bottom there, but we are saying every time you see this kind of a diagram, don't rush to say what are the answers for the questions. We are not interested in the questions at the moment, but we want to understand the information given and how does it relate to the diagram. What do we see in the diagram, and what is it that we know about everything we see here in the diagram? Already we see parallel lines, we see a tangent, it is written there, GBH is a tangent. And what do you know about a tangent? There is a circle, the center is clearly defined. We are also told that A, B, C, D, E are all points on the circle. It means that we have a cyclic quad, because if you have 4 points on the circle, then you have a cyclic quad. Now, this is very important for us, that, and we have a triangle already. I'm sure you can see that we have a triangle BABE. It's a triangle. AB is a triangle. EFD is a triangle. What do we know about those kind of structures or concepts that we see in this diagram? That is very important. That is why it is important that today, because this is a question that comes from the exemplar paper. Remember, we are talking about the exemplar papers, that your teachers surely must be having a copy of the exemplar paper. Please ask your teacher. It is written exemplar paper. It is DBE 2014. It comes from the national office to say this is an example of how our paper will look like. Let's work on it, and let's ask our teachers to actually assist us in working on these questions on the exemplar paper. Now, as we do that, before we actually can go to the questions themselves, can we just remind or highlight some of the basic concepts that we must be readily available to our minds before we answer any questions on Euclid geometry. Now, parallel lines. If we start with parallel lines, I will just draw here a parallel lines. There we have parallel lines and a transversal. So we say we have here line segment A, B, C, D, and these lines are parallel lines and transversal E, F, and then we are given angles here on these parallel lines. We are given angles here. Now, anytime we see parallel lines, anytime in any diagram we see parallel lines, the moment, like we just made an example with this diagram here, the moment in a diagram you see parallel lines, there are things that must come to your mind. And what are those things? Before you even answer the questions, when you see parallel lines, the first thing that you must remember is about alternating angles. It's about corresponding angles. It is also about co-interior angles. We'll make an example. To say angle 4, if you look at angle 4 and angle 5, I'll write it here that angle 4 is equals to angle 5. And the reason is alternating angles. Why are they alternating angles? It is because the line AB is parallel to a line CD. Look at how I write my reason. You see, we say angle 4 is equals to angle 5. Why do we say that? Those angles are alternating angles because Remember, with geometry, we must always give a reason for everything we write. So angle 4 and angle 5 is equal to angle 5. Then why? It is because those angles are alternating angles, since the line segment AB is parallel to line segment CD. So when you see parallel lines, you must look for alternating angles. Do you have any angles alternating? You can see angle 3 is also equal to angle 6. We can just write that. Angle 3 is also equal to angle 6. The reason the two angles are also alternating angles, and they are alternating angles equal. Why? Because line AB is parallel to line CD. Good. That is the first concept that we really must keep in our mind the moment we see parallel lines. The other concept is about angle 2 and angle 6. We write here angle 2 is equals to angle 6. Look at angle 2 and angle 6. Angle 2, we say it is equals angle 2. Here is angle 2. Do you see angle 2? Check how they are positioned. Angle 2 is equals to angle 6. Why are they equal? Because they are corresponding angles, and they are equal because the line AB is parallel to a line CD. Angle 2 is equal to angle 6. They are equal. Why? Because they are corresponding angles. Corresponding angles will be equal when you have line AB parallel to line CD. And I want you to note the way I write it. My reason I write it in full, I don't only say alternating angles, but I write in full, say corresponding angles. They are equal because they are corresponding angles, since the line AB is parallel to a line CD. And you also see in here there are a number of other angles which are alternating. Those are not the only angles alternating. We still have angle 1 is equals to angle 5. They are also alternating angles because lines are parallel. Angle 4 is equals to angle 8. Angle 3 is equals to angle 7. They are also alternating. So in a diagram, on your questions, once you see parallel lines, then you must think of, do I have corresponding angles? Because if there are parallel lines, then those corresponding angles will be equal to each other. I want us also again to talk to this other concept that relate to parallel lines, that you can have again angle 4 plus angle 6. When you add them, they will give you 180 degrees. Angle 4, look at angle 4 there, plus angle 6. In between the parallel lines on a transversal, they will give you 180 degrees because they are co-interior angles. The co-interior will give you 180 degrees because the line is parallel to another line. Do you see what happens? I don't only write co-interior angle, but I write co-interior angle because the line AB is parallel to a line CD. So in your diagram, this is what you are looking for. Co-interior angles, these are not the only co-interior. We can see that angle 3 and angle 5, they are also co-interior. So we can as well also for them indicate that them being co-interior, it will mean that angle 3 plus angle 5, they will also give us 180 degrees because the two lines are parallel to each other. Can I just secondly say something about perpendicular lines? Perpendicular lines. What do we know exactly about lines when they are perpendicular? When we say lines are perpendicular to each other, right, I'll draw something like this. When we say line AB, line CD, they are perpendicular, it means the angle there at the point of contact is a 90-degree angle. It is normally indicated by that sign. Perpendicular lines, we will see them by what? That 90 degrees. So we know that once you see a 90 degree, even if it is something like this, we already can tell that the two lines, line EF and line FG, the two lines are perpendicular. Let me write it here. Line EF is perpendicular to line FG, line segment EF is perpendicular to segment FG. And this is how it is indicated. But the moment we see a 90-degree angle there, at a point where the two lines meet, then you know that those lines are perpendicular to each other. Even here, look at this. this sign means that it is 90 degrees. So it already tells us that this is perpendicular to each other. There's this commonly known right-angled triangle. I'll quickly mention it here, a right-angled triangle. I'll draw it quickly here, right-angled triangle. There we are. We'll call it anything triangle A, B, C. Now in this triangle A, B, C, look at this sign here. This sign tells us what? It tells us that the angle there is 90 degrees. It means already there we have 90 degrees. In case it is said that this angle is 50 degrees here, already we will know that now, because the three angles must always give us 180 degrees when you add them, then already we will know that this other angle here, it will be 40 degrees. Why? Because 90 degrees it is given here because of the sign, and this is 50 degrees. When you add it with this one, the whole sum of angles must be 180 degrees. Is equals to 180 degrees. So these lines here are perpendicular to each other. AB is perpendicular to BC, and once they are perpendicular because of that sign, then we know that the angle there will be a 90 degree angle. Whilst we talk of perpendicular, I want to extend it here where you have the lines bisecting each other. Where we say the lines bisect each other. Bisect, right? Here we are. I'm talking about the word bisect. Bisect, it means what? It means that this line cut this other line into two equal halves. The two equal halves. If this part is 5 meters, this part will also be 5 meters. Hence we say this line bisect the other line. Bisect, it means it cut that other line into two equal halves. It is not only like a line that will be bisected, even the angles also, the angle can also be bisected. The angle can also be bisected. Let's say here we have this. Remember that sign means what? It means the angle there is 90 degrees, am I right? It means this angle, because of this sign here, the angle there is 90 degrees. But if we say this line AB bisect that angle 90 degrees, what does it mean? It means that each part of that angle is 45 degrees, 45. It cuts that angle into two equal halves. It is bisected. Bisect, it means it cut into two equal halves, like we have there on that line. But even on the angle we can have bisect. It means that angle is cut into two equal halves. This part here is equals to the other part on that other side. Please, these are the things that you need to take note of when you deal with this part in the diagram. In the statement when it says bisect, what do you know about that bisect? I want to quickly talk about a triangle. We have already mentioned something about a triangle. If we have a triangle like this, I'll write it here 60 degrees, and we have 40 degrees. Triangle A, B, C. In a triangle like this, where we know that this angle is 60 degrees and this other angle is 40 degrees, and we don't know how much is this other angle here, we then go this way. We say angle A plus angle B plus angle C is equals to 180 degrees, and the reason therefore is what? Sum of angles in a triangle. Sum of angles in a triangle. The sum of angles. Because we agree that all the angles of a triangle, when you add them, all the angles of a triangle, when you add them, they must always give you 180 degrees. So when you see a triangle, you must think about, do I have the angles there? Can I add all the angles? Because those must give us 180 degrees. So angle A is 60 degrees, angle B is 40 degrees, and C is X is 180 degrees, and therefore X is equals to 180 degrees. The additive inverse of 100 there minus 100, I think it is 100 there, then X is equals to 80 degrees. So we have found now, we have calculated the value of this other angle, which was x. Now we know that that other angle now is 80 degrees. So be careful when you see a triangle. This is what you must come to your mind. Triangle, though, can I add the angles of that triangle? Because they must always give me 180 degrees. But triangles, again, there may be an angle outside the triangle. The angle outside the triangle. If you have A, B, C, D, and BC is produced, I want to use that word, to D. Look at BC. BC is produced. BC is produced. And here we are given it is 60 degrees. This one is 40 degrees. And now we have calculated that one is 80 degrees. Now when the statement says the line segment BC is produced, that it is produced to D, it means that we have the exterior angle, the angle outside, the exterior angle, the angle outside the triangle. And what do we know about the angle outside the triangle? We know that the angle outside the triangle, if we call it Y, will be equal to the sum of two interior opposite angles. The angle outside is equal to the sum of two interior opposite angles. So it means that Y in this case, which is the angle outside, Y is equal to 60 degrees plus 40 degrees. And our reason there is what? Exterior angle of a triangle. It is the angle outside the triangle. It is the exterior angle of a triangle. That exterior angle, the angle outside, is equal to the sum of two interior opposite angles. Therefore, Y will be equal to 100 degrees. And we are happy about Y being 180 degrees because we also know that the angles on a straight line here, they must always give us how much? 180, in fact 180 degrees. So if this one is 100 and this one is 80 degrees, then we know that we have the 180 degrees. So we are happy about that. Ne? So the triangle, be aware of this kind of angles when you look at a triangle. One important triangle that I want to mention without wasting time is the isosceles triangle. Isosceles triangle. Isosceles triangle is a triangle in which case A, B, C, two opposite sides are equal in length. Isosceles triangle is a triangle in which two opposite sides are equal in length. In this triangle, look at this side. This side is equal to that side in length. It means that if side BC is 10 meters, how much is side AC? AC, when you calculate it, it will also give you 10 meters. They are equal in length. And in that case, it means that angle A will be equal to angle B. Why is angle A equal to angle B? Because these are angles opposite equal. So angles opposite equal sides. Once we have a triangle like this, where the sides are equal, then we can say angle A is equal to angle B because these are angles which are opposite equal sides. You can see that angle B is opposite that side and angle A is opposite that side, and they are equal to the sides which are equal. They are opposite, in fact, to the sides which are equal. So the two angles get to be equal to each other. Now, isosceles triangle I is only one triangle which have got two sides equal to each other, and this will make the angles opposite those sides to also be equal to each other. Meaning that if angle A is 50 degrees, how much will it be? If angle B is 50 degrees, how much will be angle A? It will also be 50 degrees because the sides are equal. So in any case where you see anything about sides equal in a triangle, this you must check. It must be in a triangle. When you see sides equal and you have a triangle, then you must begin to see, can I have the sides which are equal to each other, because we have the two. Can I have an isosceles triangle? Because here there it is, there are sides which are equal to each other. I quickly want to talk about congruency. Congruency. These are things that we need to look for. Now, congruency will need us to have two triangles. You see, isosceles is only one triangle. Isosceles triangle. But for congruency, you need to compare two triangles. A, B, C, and another triangle again. Triangle D, E, F. In these triangles, if you have side AB equal to side ED, side BC equal to side EF, and side AC equals to side FD, then we can see the two triangles are congruent to each other. And this is the sign. Triangle ABC is congruent to triangle DEF. And the reason there is side, side, side. In the congruency, you compare two triangles. And what does congruency mean? Congruency means that these two triangles are the same in shape and size. Same in shape as well as the size is the same. They can fit exactly one on top of the other. Like these two pages here. You see, if I put this page here, and I can fit this other page exactly on top of the other one, then we say those two pages are congruent to each other. But basically for us, we work with triangles. But any polygon where the shape is the same and the size is the same, for two polygons that you compare, then we say they are congruent. But for us, we mainly focus on triangles. Now, congruent, what does it further mean? It means that once they can fit on top of each other, in this case, because of the side, this side equals to that side, this side equals to that side, that other side equals to that side, they can fit very well to each other. What does it mean? It means that if this angle is 45 degrees, the other angle will also be, everything is the same. We only proved three things about the size, but that means even the angles, everything of the two triangles will be the same shape and same size. We only proved three sides to be the same. Therefore, we can conclude that everything on this triangle must be the same, because we have proved that the three sides are equal. Again, in other triangles, it can be side, angle, side. You can also prove congruency, angle, side, angle, 90 degrees, hypotenuse, side. I'm sure these are the four conditions that we need to be aware of for triangles to be congruent. And like I'm saying, if you prove one side, angle, and one side, let me just draw that one quickly. We have a triangle here, we have another triangle there, and we say this side is equal to that side, this angle here is equal to that angle, this side is equal. You see these two triangles. Once we say these two triangles are congruent, side, angle, side, side, angle, side. I've talked about these two conditions now, two of them. Side, angle, side. And you see this an included side, angle in fact. It is the angle between the two sides, angle between the sides, angle between the sides. Once we have proved that the conditions are fulfilled by the two triangles, then we can say those two triangles are congruent. And maybe I should write it in full here to say triangle ABC, triangle DEF. Then we can conclude that triangle ABC is congruent to triangle DEF. The reason is side, angle, side. And we can see the angle is between the two sides. Now those two triangles are congruent to each other. So in your exercises of geometry, when you deal with them, look for those. If you have two triangles, can you check if the two triangles are congruent? What does it mean to say triangles are congruent? Exactly. This to say triangles are congruent, it means that they can fit on top of each other exactly. They have the same shape, they have the same size. Meaning that if this angle is 20 degrees here, this angle here will be also, what's that angle? It will also be 20 degrees. You see, we did not talk about the other angles. Can you see that? But we have only checked three three characteristics of these triangles, which is a side, the angle, and the side. We did not talk about other things. But if we can prove this one for congruency, we can therefore say, surely, this angle, if it is 20, the other one will also be 20 degrees. If this other angle is 102, 102 degrees, this angle will also be 102 degrees, because we have already proved that they are exactly the same shape, they are exactly the same size. If this side here is 10 meters, this side must also be 10 meters, because we have already proved that the two triangles are congruent to each other. Good. That is congruence. I'm sure you see the difference now, that isosceles triangle is only one triangle, where angles opposite equal sides will be equal. Why? Because the opposite sides are equal to each other. But congruency, you need to have two triangles. There must be two triangles for you to say these are congruent. And these are things that you will see in your exercises when you answer the question paper. When you see two triangles, then you must think of what? Congruency. Can I prove congruency on these triangles? But if you see one triangle with two sides equal, you think of what? Is this the isosceles triangle? What do I know about isosceles triangle? But again, for two triangles, there's again the concept similarity. Similarity. Let me write here that triangles are similar. Similarity. Good. This also needs two triangles. A, B, C, triangle D, E, F. Now, in these two triangles, look at the two triangles now here. We said congruency, you need two triangles, isn't it? Yes. Even similarity, you need two triangles. Now, for similarity now, you need to have the triangles which have the same shape, but size not the same. Not same. And you look at these two triangles. Are they the same in size? No. They are not the same. The other one is bigger than the other one. The other one is smaller than the other one. But remember, similarity, like you proved it with your teachers, that if the triangles are similar because of corresponding angles are equal, then the sides are in the same proportion. So the sides are not necessarily like they are bigger, but they don't correspond to each other. The corresponding sides should be in the same proportion, right? But key is those two triangles are similar because they have the same shape and the size is not the same. Size not the same, but the shape is the same. They have the same shape, but the size is not the same. Now, when we prove similarity in any given situation, when we work with similarity in any given situation, we need to identify our triangle. Say, in triangle ABC and triangle DEF, the triangles must be clearly identified. That these are the triangles that I'm going to work with. We will quickly look at this exercise. You see, this exercise has got a question on what? Prove that triangle CBD is similar to triangle CEB. So you must color your triangles and identify and say, these are the triangles I'm going to talk about. We must prove that these two triangles are similar to each other. Now, what do you need to do? You must write and say, look, in those two triangles, you identify and label correct in those two triangles. The statement here, this is what I prefer for my learners as to how should they write when they actually work on this geometry questions. Look, you write there in those two triangles. You write there that number one, angle A is equals to angle D. Do you agree with that? Angle A is equals to angle D. Angle A is equals to angle D. And you write your reason this side. Here you write the reason. Well, in our case here, we can just say the reason, it is given. This was given to us. Given. Because there it is, we can see that the two angles are equal. Number two, you say number two, but you need to look at your triangles and write the appropriate reason. When you look at your triangles, You use all the theorems that you have learned, everything that you have learned about parallel lines, if it can apply there. Everything that you have learned about anything, isosceles triangles, whatever, in fact it should be two triangles, anything that you have learned about the theorems, circle theorems that you have learned in grade 11. Now you need to write the appropriate reason that is actually required there. Then you go on and say angle B is also equals to angle E, and you also give the appropriate reason there. Well, it is given maybe in this case, we can see that. And then lastly we write there again that number 3, angle what? Angle C is equal, angle C in this triangle, we compare it with the other triangle, is equals to angle F. We can write the third angle of the triangle, or in this case it is the given, but it depends on any reason that is given that you need to assign. But it's important that when you say the two angles are equal, you must write the reason. When you say these two angles are equal, you must give the appropriate reason. When you say these two triangles, also give. But basically, if the first two angles are equal, obviously the third angles should be equals to each other. That's why we say third angles of a triangle. Now, you say, therefore, I can conclude that triangle, I want you to look at how I write this now. I can conclude that triangle ABC is similar to triangle DEF. Where do I take ABC? When I make my conclusion here, very important, I must write the triangle in the order in which the angles were actually proved to be equal. If I started with angle A here, it must be triangle ABC. So here I write it in this order here. Triangle ABC. Can you see that? Is similar to triangle what? DEF. I use the order that I have here when I write the triangles to be similar, and I give that the reason that the reason is angle. The three angles are equals to each other in those two triangles. I want to emphasize this. Please take note of it, teachers. Please put it in correct perspective when you deal with exercises on this with your learners. 1 or 2 exercises will do, because I take it that your learners at least knows the theorems and everything. When you write here, look, I use this other color here, the triangles. Please write them in this order. Triangle ABC is similar to triangle DEF here. Please use that order of angles. You cannot say triangle here, triangle BAC here. You cannot. You see, BAC. You can't do that. You need to write it in this specific order that you have proved your angles to be equal, which is triangle ABC. Why is that important? It helps us to continue to the other part of sides being proportional. To say the side AC, look at AC. You can do that with a pencil. Over side DF. I want to write that down now. Side AC over side DF will be equals to, because the triangles are proved similar, then the corresponding sides are proportional. Side AC over side DF is equals to side BC. Look at BC. Do you see BC this side? I take the same order even this side. Over side EF. Can you see that? Let me write it down now. Side BC over side EF. I take exactly the same order that I've used here. BC over side EF is equals to, the last side is what? I think this AB. Ne? AB, look at AB, over DE this side. AB over DE on the other side. And you see what I've done? I've wrote all three ratios together, all three of them. I not only write part of the ratio, but I wrote all three ratios. So once we have proved your triangles, remember this, my children, once you have proved your triangles to be similar, the reason is okay. When you write your ratio there, write all three, because once you have proved the triangles to be similar, The next question will be asking us about sides which are proportional. Look at this question. The triangles are similar there, and therefore the next question says what now? Talk about sides being proportional. This is a question paper 2010. Your teachers, if they can note it down, 2010 November is a paper 3, 2010 November. That's where I got this exercise. You see that you prove similar. Thereafter, what you do, then you come to proportional sides. Now, for proportional sides, I want you to remember this, that this is how you identify your sides to be proportional. And you write them down, all three ratios. It is from these three ratios that you'll identify to say which ratios do I need to answer the question. Maybe you actually need these two to answer the question, which is AC over DF is equals to AB over DE. Maybe you only need those two, but after proving similarity, write all three ratios, and then it will depend which two are you going to use now to answer the specific question which is asked in that case. Now, please remember what we have talked about similarity. Similarity, it must be about two triangles. If the question says prove this is similar to that, then you must look for two triangles. Identify your triangles clearly, that this is the triangle and that other triangle. And write three angles which are equal. The statement, and you must give the reason for each statement that you write. This is the angles equal, the reason. The angles equal, the reason. The angles equal because obviously the third angles of a triangle will be equal as well if the first two are equal. Thereafter, when you write your triangle here, write in the order in which you wrote your triangle ABC. The order in which you wrote your angles is equal to triangle DEF. I'm not even looking at what I wrote there, but I'm now interested in the order in which I wrote my angles. That's how I write the triangles to be similar and the reason there. And thereafter, then you can now look for your proportional sides, and at least I've tried to make the different colors to mark them. The side AC in this side, do you see how it is? Even this side, you must take the same order, DF. Side AB over side DE, side BC, look at the order, BC must be also over side EF. I did not say side AC over side DE. The order is not correct. AC goes with DF. So that order becomes important, and then you write all three ratios that you wanted to write there. Very good. I want us now to quickly look at this. This is the examination guide. The examination guide gives us the reasons that we can use in Euclid geometry. You need to write the alternating angles. Why are they alternating angles? Because AB is parallel to CD. Alternating angles because AB is parallel to CD. All of your teachers. My children, I'm sitting here. I have met all of your teachers, the whole province. I met with them. I made sure that each of your teachers have got this page. They have it. The subject advisors can be phoned at any time to assist your teachers to have this copy, because these are the reasons that we must use when we actually answer the questions on Euclid geometry, about triangles, about all other. Look at them. We have circles as well. The tangent perpendicular to radius. That theorem where the tangent is actually perpendicular to a radius at a point of contact. And we know what perpendicular means. It means at that point we have a 90 degrees. When the tangent and the radius meet here, when the tangent and the radius meet, what does it mean? At that point, perpendicular. At that point, it means we have 90-degree angle, a 90-degree angle. All the theorems there are there, and the appropriate reasons to give when you answer some of the questions here. One of the popular theorem, it is the Tancourt theorem. Tancourt theorem. Tancourt theorem, you remember it as well. If there is the tangent, what do I have here? Something like this. This angle here, the angle between the tangent and the chord is actually equal to the angle in the alternate segment. The angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. It means that this angle there is equal to that angle. It's one of the popular theorems as well. Please be aware of it. The tan chord theorem. Sometimes we are just tempted to write tan chord. Please write it tan chord theorem. This is the appropriate way to write your reasons when you answer the questions. Remember I said in Euclid geometry, every time you have a statement that you make, there must be a reason. Write a reason at all times. Give a reason. Even for parallel lines and everything, every time give a reason for any part that you actually want to deal with. I want us to look at this. Maybe we can have a short 5 minutes break that you just look at your notes, and when we come back, we then talk to this exercise. It was there in our discussion yesterday, the exemplar paper. I like the exemplar paper because it's actually one of the papers that give us the example as what you must expect in the final examination paper, and it covers everything that you have done with your teachers. Look, when I give you this exercise, remember what we did? We say we are interested in the diagram before we can go to the questions. Let's have that 5 minutes break. When we come back, we'll try to fit in 2 exercises to deal with. Thank you very much. Yes, welcome back. Let's see quickly if we can try to apply 1 or 2 of the concepts that we mentioned earlier on. It was important for me to start with that background because we need that background before we can answer any question. Look at the diagram we have here. The diagram we have here, question 8, I said it comes from the exemplar paper. Please deal with it with your teachers. When you look at this, we need to read the statement and relate it with the diagram here. Now let's try to do that. In the diagram, A, B, C, D, and E are points on the circumference of the circle such that AE is parallel to BC. Now already that means to us that BCDE is a cyclic quad because the points are on the circle. Do you see that? If the points are on the circle, it means that the 4 points on the circle now give us what? A cyclic quad. And cyclic quad, we know that opposite angles of a cyclic quad are supplementary. Opposite angles of a cyclic quad are supplementary. They give us 180 degrees. But it goes further and say AE is parallel to BC. AE is parallel to BC. It means that this angle B3 and angle E1, if I'm correct, those 2 angles are what? Alternating angles. Can you see that? Those 2 angles are alternating angles. I hope I have them correct. Can you see that? They must be equal to each other. They are alternating angles. Good. Maybe you should use a different color there to show that these 2 angles are alternating. Now this is what you must do in your script as well. The diagram sheet that is given to you, you can use a pencil, you can use any other colors to actually mark on the diagram. Don't doubt to mark on the diagram. BE and CD are produced to meet in F. They are produced to meet in F. Now that means that the angle you have here is the angle on the straight line. They must give you 180 degrees. You have the exterior angle is equal to the interior angle of a cyclic quadrilateral. So I can mark that this angle actually with the same color as this other one. Do you remember these are equal because they are alternating parallel lines. But now this exterior angle will be equal to the interior opposite angle. And the same thing will happen with these other 2 angles here. Angle E3 exterior angle, look at E3 exterior angle will be equal to the interior opposite angle of a cyclic quadrilateral. Those angles are equal to each other, right? Maybe I should cancel this one. This was about opposite angles are supplementary. But now here we are making them the same way because these two are actually equals to each other. It goes further and says the statement here now, GBH is a tangent to the circle at B. Here is a tangent to the circle. What do we now see here? If this angle is 68 degrees, I want to mark using the same color that we have used initially. This angle here, the angle here is the same as the angle there. Do you agree with that? The tan-chord theorem. Angle between tangent and the chord. Angle between tangent and the chord is how much? Is equal to the angle in the alternate segment. Do you agree with that? Now, if this one is 68, this one is 68. But now look at the same color. This one is 68 degrees. This is also 68 degrees because of alternating angles. The lines are parallel. This one is also equal to this one because the exterior angle of a cyclic chord is equal to the interior opposite angle. So the tan-chord, the tangent, it means that the tan-chord theorem can also apply there. We are given that angle B1 is 68 degrees, angle F is equals to 20 degrees. Now look, if this angle here is 68 degrees, these are equal because the exterior angle of a cyclic chord equals to the interior opposite angle. Look at the same color. It means that same color means 68 degrees, 68 degrees. Now here is 20 degrees and 68 degrees. Can you help me? Already we can see that there's a triangle there. We have 68 degrees. I'm writing down here. 20 degrees, 8, 88, 108. 180 minus 88 is how much? 10, I think is 2 there. 17 minus 8, is it 92? I hope it is 92. So it means the angle here might be 92 degrees. Do you realize that? The angle there must be 92 degrees because they are angles of a triangle. The sum of angles of a triangle. The same colors took us back to 68 degrees, 68, 68, 68, 68. We have the reasons, but now this is a triangle, 20 degrees plus 68. I hope I have this calculation correct. You'll help me out there. But the angles of a triangle must give us 180 degrees. 10 minus 8 is 2. And here it is 17 minus 8. I hope it is 9. Yes, 17 minus 8 is 9. Right? 92. Right, 92 degrees. So it means this angle here will be 92 degrees. I hope that is correct. Please help me with the maths there. Okay, good. So we have that and we have wrote them. You see what I want to also mention, that don't hesitate to write these things on your diagram sheet. It is given at the back of your question paper, the diagram sheet. Write this stuff. Write this stuff that you are noting here. Write it in your diagram sheet. Once we have done that, and you are happy with your diagram, I don't know if we have covered almost everything, but we look at the statement and then we come to the diagram. And we note on the diagram sheet things that we know about what we see here. What do we know about parallel lines? Remember, we have talked about that. Alternating angles are equal because their sides are parallel. Corresponding angles, co-interior angles. What do you know about a triangle? What do you know about cyclic quadrilateral? All 4 vertices are on the circle, and it was written here that the 5 points are on the circumference of the circle. So 4 vertices will make a cyclic quadrilateral. Once we have produced, it means the exterior angle of a cyclic quadrilateral will be equal to the interior opposite angle, and so forth and so forth. Then we can go to see at the questions now. Let's look at the question in relation to what we have talked about quickly now. Now, the questions, as you can see them now, it says, determine the size of each of the following. Angle E1. Angle E1. Look at angle E1. How much is angle E1? Already you can see the colors. There is angle E1. So you quickly write there now that angle E1, you quickly write there that angle B1, let me write somewhere here so you can see. Angle B1 is equals to angle E1. They are equal to 68 degrees. Do you agree on that? Angle E1 is equal to angle B1. They are equal to 68 degrees. And the reason is what? The tan-chord theorem. Remember the reasons that are given on that examination guideline. We must write tan-chord theorem, not tan-chord. tan chord theorem. The colors already assist us. E1 is equals to B1 and B1 is equal to 68 degrees. I'm sure that answers the first part. The second part says, how much is angle B3? Look at angle B3. Can you see angle B3? Isn't angle B3 equals to angle E1? Do you remember the reason there? Let me write it down. Angle B3 is equals to angle E1. And they are both equals to how much? To 68 degrees. Why? Remember what we talked about the parallel lines? Do you remember that? We write the reason there is alternating angles. Why are they alternating angles? Because the side AE is parallel to the line segment, I think BC. There it is. You see how do we now write our reasons? And it becomes easy because the colors are there. Look at the colors. They tell us that 68 degrees, the tan chord theorem. 68 degrees, they are alternating angles. Can you see that? Right, we continue. The next question says, how much is angle D1? Ooh, look at that. Everything falls into place because our colors can easily show this out. Angle D1, we looked at the diagram first before we can come to anything else. Angle D1, look at angle D1. Doesn't it have the same color as angle B3? Do you remember what did we say there? Number 3. Angle D1 is equals to angle B3. They are both equal to 68 degrees. Why do we say that? The exterior angle of a cyclic quadrilateral. The exterior angle of a cyclic quadrilateral. Everything can just fit in there. The exterior angle, and you look at the diagram, angle D1 is equals to angle B3 is equal to 68 degrees. The exterior angle of a cyclic quadrilateral. Good. Are you happy with that? This is a question paper that your teachers have. I want you to go back to it and work on this again. Angle E2, look at angle E2. Angle E2. Do you see angle E2 there now? Angle E2. Can you see angle E2? Right. Angle E2 is this angle. But it is, remember we talked about a triangle. Angle E2 is the exterior angle of a triangle is equal to the sum of two interior opposite angles. Do you remember that? So we can write now that angle E2 is equal to what? To angle F plus angle D1. Do you agree to that? The reason is exterior angle of triangle. Angle E2 is equal to, if you remember we talked about this earlier on, if we have a triangle, the exterior angle will be equal to the sum of two interior opposite. The angle outside this triangle, the angle outside the triangle, this angle, exterior angle, is equal to the sum of two interior opposite angles. Are you happy with that? And how much is angle F? We have calculated, it is given there, 20 degrees. Angle D1, we have calculated it, above is 68 degrees, and therefore angle E2 is how much? 88 degrees. Are you happy with angle E2 is 88 degrees? Already some of you are saying, but we have calculated angle E3 is 92. There are angles on a straight line. So whatever way that you can use, but just write reasons for every statement that you can use. Make sure that you write the reasons for everything that you can use. And the angle C is the last angle now. Angle C. Now angle E2, how much is angle E2? 88 degrees. We have just calculated it. Do you see that? Angle E2 is 88 degrees. Now angle C. And angle C, look at angle C. Angle C plus angle E2, they must give us 180 degrees. Why? Opposite angles of a cyclic quadrilateral. Do you agree to that? Angle E2 plus angle C. We talked about this at the beginning, remember? Angle E2 plus angle C must give us how much? 180 degrees, because they are opposite angles of a cyclic quad. Already angle E2 is 88. So we write angle C will be equal to 180 degrees minus 88, the additive inverse there, and therefore angle C2 is equal to 92 degrees. Are you happy with that? Do you see that? Because angle E2 is 88 degrees, the additive inverse becomes negative 88. What you do every time on the left, you must do on the right. If you put the additive inverse of E2, which is 88 minus 88, then you must do that minus 88 on the right as well, because this is an equation. Good. So angle C becomes 92 degrees. And we are here because angle C is 92 degrees. Already you could see that angle E is 92. The exterior angle is equal to the interior opposite angle of a slightly quadrilateral. I'm just using that exercise just to show that it's important for us to read and write the marking. If you can, take along your pencil, a blue pen, take along any colors to the examination room, write on this diagram. Don't hesitate to write here, but make sure, have a reason for each and everything that you write there. Just have a reason for each and everything that you write there. I quickly want us then to look at this other exercise. We will try to do the same thing on this exercise as well. We will try to do, it's a question paper 2010. It's a question paper 2010. Your teachers, please take note of that. It's a question paper 2010. Even on this question paper, are we really going to rush to the questions? No, we really are not going to rush to the questions. We first are going to look at the statement. The statement here, 8.2. We are going to read this first, and then we look at the diagram. We will come to the questions. We will definitely come to the questions. But we look first at the statement and then come to the diagram. Right? When you look at the statement, ED is a diameter of the circle. That is very, very important. ED is a diameter. ED is a diameter. That is very, very important. Once you say ED is a diameter of the circle, what do you know about a diameter? ED is this is the center. ED is a diameter. Now it means this angle here must be how much? 90 degrees. A diameter subtends a right angle on the circle. It means angle B23 must be what? 90 degrees, because ED is a diameter. That statement is important with the center O. ED is extended to C. Now ED is extended to C. It means this can be an exterior angle. It means we have a straight line there. It is 180 degrees there. And D2 is an exterior angle of a triangle equals to the sum of two interior opposite angles. Beautiful. CA is a tangent to the circle at B. CA is a tangent. Oh, tangent. It means this angle here, chord theorem. The angle between tangent and the chord. This angle B4 must be the same as angle E. And we can see angle E is tan chord is. Angle E is X, therefore angle B4 must be X. Can you see that? The tan chord theorem. You know the tan chord theorem. A tangent, and there you are, there you are. The angle between the tangent and the chord must be equal to the angle in the alternate segment. Here it is. The angle between tangent and the chord is equal to the angle in the alternate segment. And angle E here is X. It means angle B4 must be X. AO intersect BE at F. Take note of AO, they intersect. They just cross each other there. They intersect here at F. At this point F, they intersect each other. Are you happy with that? Good. BD is parallel to AO. BD, what do you know about parallel lines? Alternating angles are equal. Corresponding angles are also equal. Co-interior angles give us 180 degrees because the two lines are parallel. So if that is the case, we look at the two parallel lines, but we see now this one is 90 degrees. It means this one also is 90 degrees. Am I right? They are co-interior angles. Can you see that? They are co-interior angles. Do we have any alternating angles? Yes, we have. Angle 02 is alternating with angle B3. They are alternating angles. And so forth, and corresponding angles. Angle D2 is also corresponding with this angle 01 and 2. Do you see angle 01? They are. We are well aware of those things. We are alert. We have opened our eyes. We are aware of those. Now, it is given that angle E is X. So angle E is X. It means angle B4 is also X. Now, if angle B4 is also X, we check around. Do we have any other angle that can be X? No. These lines are parallel. These lines are parallel. Parallel, it means this angle can also be X. Do you see that? Corresponding angles are equal. Corresponding angles are equal. Are you happy with that? Good. Because this is the center, 0E, 0B. If this one is X, this must definitely be X as well. Why? Because the radii are equal in length. the radii are equal in length. Do you remember the isosceles triangle we talked about? This side is equal to this side. It means that angle must be equal to that angle. 0e, because that's why it was important that we are told that 0 is the center. So if it is the center, 0e is a radii, 0b is a radii, 0d is also a radii. They are all equal. So these are, maybe I should also mark that one. They are all equal. But now in this triangle here, these two, they are like this. It means that we have those angles opposite equal sides equal as well. We are fine. We have made our marking here. Are you happy with that? That's good. Then we can see if we can now deal with the questions. The first question says, write down with reasons. With reasons. Very important. With reasons. 3 other angles equals to x. Ooh, we have long marked those already. Can you see that? They are already marked there. Angles with reasons. They are already marked. Let me use what we have here. They are already marked there. Can you see that? With reasons, right angles that are equal to that. Angle B4 is the first one, is equal to x. The reason is what? B4 is equal to x. The reason is, remember, the tan chord theorem. Tan chord theorem. The other angle which is equal to x is which angle? Angle A, we have marked x there. Angle A is equal to angle B4, which is equal to x. Why are they? Because corresponding angles. Corresponding angles, why are they corresponding angles? We need to write there that BD is parallel to AO. Do you see that? Corresponding angles. Do you agree with that? Corresponding angles, parallel lines, we need to check. Is there alternating angles? Is there corresponding angles? Is there co-interior angles? The last angle also equals to that is B2. Angle B2, we have just talked about angle B2 is equals to angle E. Am I right? They are equals to x. Why? Because here they are equals to x because BO is equals to OE, and that because they are equal because they are radii, that makes what? Angles opposite equal sides to also be equal. We can write there angles opposite equal sides are equal. Good. That is the reason there, right? Because of the radii. So we have all the 3 angles which are actually equals to x. The other question, right, says quickly, determine with reasons CBE in terms of x. CBE in terms of x. So we write there for CBE. We try to write it in terms of x. CBE in terms of, remember we said now earlier on that DBE, do you remember that angle? DBE is equals to 90 degrees. Why is it equals to 90 degrees? Because this angle in the semicircle, it is subtended by the diameter. Do you remember that? That DBE, because this one is a diameter, that becomes what? A 90 degree angle. That angle there becomes, now if that one is a 90 degree angle, angle CBE will be 90 here plus x. Do you agree with that? In terms of x, angle that will be 90 degrees plus x. Good. Are we happy with that? Good. We are just going through them so that we can see our marking. How does it help us to answer the questions here? It helps us a lot to answer this kind of questions here. Right, I want to keep the diagram so that we can see the marking that we have done. They help us because 90 degrees plus x, here it is. This one is 90 degrees because subtended by a diameter, and we have x there. So CBE becomes 90 degrees plus x. The question said your answer must be in terms of x. And the next question now says, prove that F is the midpoint of BE. Show that this F is the midpoint. Now, how do we show that is a midpoint? Remember the theorem, I'm sure it is the very first theorem on our circular geometry, that the line perpendicular to a chord bisect the chord. Once we can show that this line is perpendicular, if we can show that this is 90 degrees, then we then know that it bisects the chord, meaning that F becomes what? The midpoint. Do you understand that? That theorem, I'm sure all of you can remember the theorem. We just need to show that that angle there is 90. If we can show it is 90, meaning perpendicular, then we can conclude that it bisects the chord, and if it bisects the chord, it makes F to be the midpoint, right? Let's go now. Now we can say now here, DBE 90 degrees. Angle DBE is equal to 90 degrees. It has been proved. Remember, we have talked about that. This angle here, DBE, is 90 degrees. We have just talked about it. This angle here, right? Do you see that? If this angle is 90, you realize that these two angles are what? The two sides are what? Parallel lines. Parallel lines. Do you remember? Don't forget the parallel lines. That's why we said 90 here. But why do we say it's 90? We say angle BFO is also equals to 90 degrees. Why do we say that? Co-interior angles. Why are they co-interior angles? Are supplementary. Why? Because BD is parallel to AO. Yeah. Ooh, you can't see that, right? Let me do like this, right? Yes. These two. This is also 90 because what? Co-interior angles. This is 90. This will also be 90 because they must give us 180. They are angles between parallel lines. Co-interior angles are supplementary, 180 degrees. 90 plus 90 is 180 because the lines are parallel. Therefore, BF must be equal to FE. Ooh, I'm trying to show all the stuff I have. Therefore, BF must be equal to FE because this is 90. Remember the theorem we talked about. If this is perpendicular, then this must be equal to that. And once that is equal to that, F is the midpoint of EB, right? F is the midpoint of EB. Remember the question was say, let's show that that is the midpoint. Then F is the midpoint of that, right? Quickly, let's look at this one now. It says similar. Prove that the triangles are similar. I'm trying to fit in everything here, and I want to keep this diagram as well. Prove that triangle CBD is similar to triangle CEB. Prove that triangle CBD. Now we need to write, remember what we said here, we must write in triangle. You must write your triangles. In triangle CBD and triangle CEB. In those two triangles, you identify your triangles correctly. In triangle CBD and triangle CEB. And you can use the color CBD. Can you see that blue color there? CBD, do you see that? CBD, can you see that? Blue color there. You can color the triangle there. And triangle CEB, the big one, CEB. Can you see that? Now we must write in those two triangles, number one. What do you see about the two triangles? Number one, we can see that angle B4 is equals to angle E. Do you agree? Angle B4 is equals to angle E. Can you see they both have XX there? And what is the reason for B4 equals to angle E? We talked about it earlier on. I'm sure it is tan-chord theorem. The reason there, tan-chord theorem. Do you agree with that? Normally I write it, I like it when we have the statement and the reason. Yes, something like that. Statement and the reason. Number two. Let's look at that. In the small triangle, which other angle is equal to the one in the big triangle? Look at the small. It's got CBD, the big one, CEB. So it means C, it is there in the small. C is there in the small. Again, C, it is there in the big triangle. Do you agree with that? Angle C is equal to angle C because it is a common angle in both triangles. Do you agree with that? Right? And lastly, the third angle, obviously, angle D2 will be equals to angle B in that other big triangle because that is the third angle of a triangle. The third angle, obviously, they will be equal because the first two are equal. Now, we have those three pairs of angles equal to each other in the two triangles. Therefore, we can conclude that, therefore, triangle. Now, remember what we said. I said here, now that we have written this, you must write your triangle in this order of angles. in the order. Let me use this colored chalk. It will be triangle BCD. Triangle BCD in the order of the angles is similar to triangle ECB. Do you see that? Triangle ECB. We write them in the order in which we wrote the angles. BCD is similar to triangle ECB. It is still the same triangle in any case. BCD, it is still the same triangle. But now here we want to write it in the order in which we have proved the angles. That is very important. And for the next question, without wasting time, look, it talks of now sides being proportional. Can you see that? Now, because we wrote it in this manner, we are able to say BD, EB. So we say BD over EB is equals to what? CD. Do you see CD? The order is CD over CB. I hope it is fine. And then the last one is what? BC. BC over EC. BC over EC. Good. Now, when you look at the question now, the question we can see you have CEBD, you also have CB. So it means we can take this, we can take that ratio, we can also take the ratio BC here, because look at this now, BDEC, BD here, CEBD, EFCB. Now we take the ratios that will assist us to answer the question there. So we say for the next question now, we say BD over EB is equals to what? BC over EC. We only chose two ratios. There were three. We wrote all three of them, but we only chose those two. And we need to write a reason that similar triangles, therefore sides in proportion. Right? We do this if the reason must come here to say the triangles are similar, so sides must be in proportion. This reason must also come up here. Similar triangles, so sides must be in proportion. Now we only took those two sides. Side EB over side BD is equal to side EC over side BC. There we are. Are we happy with that? Then, but we know we can multiply out here. I think when you multiply out, you have EB, here it is, EB cross multiply, EB, BC is equals cross multiply here is equals to CE over BD. There, when you cross multiply here, you cross multiply, right? But we have realized that, does it also show here? Yes. But we have realized that EB itself, EB, remember EB, that side EB, the side EB is equals to side EF. Why do we say that? Side EF. EB is 2EF. Why? Because this has been proved to be midpoint. If it is the midpoint, it bisects these two sides. Bisect the two sides. Midpoint bisect the two sides. So EB can be EF plus EF because they are the same. Now each is 2EF. Therefore, F is the midpoint. I think the reason there F is the midpoint, right? It has been proved. F is the midpoint, right? Therefore, we can therefore write here for EB. Do you see EB now here? EB, we can write for it 2EF CB or BC. Here it is. EB is 2EF. BC is there. It is equals to CE multiplied by BD. Please go through this again with your teachers, but it was important for me to explain what we have done here for similarity. The moment you write your angles there with the correct reasons, your angles there, Then you must write the order of triangle, the order for angles of your triangles in that same order. BCD, triangle BCD is equals to triangle ECB, triangle ECB. That helps you to write your sides in the correct proportion. It helps you to write your sides in the correct proportion. And the reason they're similar triangles, it means the sides are in proportion. And therefore you can pick the two ratios that you are going to use now to answer the questions as you see it up there. My learners, thank you very much. This was part of paper 2. I know that from now onwards we'll have more time now to work on paper 1, so that by the time we come to Friday, we are comfortable with paper 1. Let's use this opportunity to get these small tips of things that are left behind, so that we can answer the questions when they come at the end of the year. Thank you very much and good luck. I'll remain to say to you good luck, because I know we are busy working for that luck to come on our side. Thank you very much and bye.